We're going to continue to talk about the basics of elementary school statistics. In a previous video, we talked about formulating questions and collecting data. In this video, we'll talk about analyzing data and interpreting results. This is just going to be an overview. Data analysis is a huge topic, and we'll have more videos getting into the details of that. Let's imagine a scenario where we have an elementary school classroom that has a bin full of beads. We could ask the question, what colors of beads are in the bin? We could collect data by reaching our hand in and grabbing a handful of beads and then examining the beads. At a basic level, we could make what's called a real graph, where we literally build a graph out of the beads. There are lots of different data representations that we could make here. We'll talk about a few of them, and as I mentioned before, there will be future videos that go into depth about these different graph types. So notice down here I've created a table that has each color and then the total number of beads associated with each color. So we could have a table of data. We could create a pictograph, which is just a slightly more abstract version of our real graph. Here, instead of actually stacking up beads, I'm going to draw circles that represent the beads. And so each circle is one bead. And so there I have my pictograph representing my handful of beads. You can imagine that if you kind of blurred together these circles, you could form a column, and that column becomes our bar graph. So the bar graph and the pictograph are very similar here. Let's look at some of the features. They both have titles, colors of beads. They both identify what the different categories are. And then the bar graph has a vertical axis that starts at 0, and the height tells the total number of beads in each different category. Down here we have a pie chart. And the pie chart looks at the number of beads relative to the total. So back here at our table, we could add up the total number of beads and see we have 19 beads. And for example, if I looked at the pink, I could say that at 7 of the 19 beads are pink, which ends up being 37%. So this wedge over here on my circle represents the pink beads. And this is a neat graph because it gives us the pink relative to the whole. So the whole is our circle, and it represents the whole handful. On the bar graph, we don't see the whole. We'd have to add up the total for each of the columns to get the whole. So it can be hard to see the relationship between one part and the entire whole in a bar graph, whereas in a pie chart, each wedge is relative to the whole, so we can compare the part to the whole. The pie chart is useful for that part to whole comparison, and the bar graph here is useful, especially if you want to compare two different categories, so part to part instead of part to whole. We don't create graphs for the sake of creating graphs. We create graphs to organize the data and then to analyze the data so we can understand what's going on. Data analysis can get very sophisticated. We're going to stick with just an elementary data analysis, not even getting to things like mean and median in this presentation. So let's look at some of the levels of data analysis of reading our graph. So to start with, we need really basic skills. Just read the data off the graph. If we ask how many beads are pink, we could come down here to our bar graph, find the pink category, and read the top here and say we have 7 pink beads right there. Literally just reading the data off the graph. Then we can read between the data. This is a little more sophisticated because this requires us to compare two different data points or to do operations between categories here. So let's look at the first question. How many more pink beads than purple beads are there? Here we might go down to the pictograph, find our pink and purple beads, and count how many more. 1, 2, 3, 4 more pink beads than purple beads. We could have gotten that from the bar graph by subtracting, by taking 7 pink beads, take away 3 purple beads, 4 extra pink beads. Let's look at another one. So we could also ask what percentage of the beads are pink or purple. So here we're having to combine two different categories. So let's look at the pie chart over here. We have our pink and we have our purple. So roughly speaking, this is about half, or about 50% are pink or purple. We could get more detailed, add those numbers up, and see that it's actually 53%. But here we're looking at the combination of pink and purple beads relative to the whole. Another thing we might do is read beyond the data. This often takes advantage of additional knowledge that you might have. So the question, would you expect the same percentage of pink beads if you took another handful? Well, I might have some knowledge of that bin of beads. If I know the bin of beads is well mixed, then probably a second handful will look like the first handful, and I would expect to have the same percentage of pink beads. If I knew that all of the, I don't know, big marble-like beads were at the bottom and I had just picked up the small beads, then it would depend where I took my handful from, and I might say no, I would expect a different percentage. Next, we'll look at data interpretation. So here with the interpretation step, we're trying to make meaning of our data. We're putting a story around our data to explain what it means. This is a dot plot. Notice that there are numbers running along the base, and each dot represents a single data point. So there were, 10 minutes. 7 people took 10 minutes to eat breakfast. So 10 minutes, there's 1, 2, 3, 4, 5, 6, 7. We could work on asking questions about this. We could say, read the data. How many people spent 10 minutes? 7 people. We could read between the data. We could say how many people spent more than 5 minutes. Well, 7, 10, 12, 16, 17 people spent more than 5 minutes. Or we could go to the next step where we talk about interpreting data. So the analysis, right, we would agree that 7 people spent 10 minutes, but the interpretation is where we try to explain this data or put some meaning to the data. So I might interpret this to be, well, most breakfasts are grab and go, or they're quick like a bowl of cereal. So probably these people were grab and go, and these people were quick like a bowl of cereal. And most people don't spend very long on breakfast because breakfast meals tend to be not very elaborate. Whereas you might have a different interpretation of what this data means.